Hello students, welcome to the next lecture on the GATE mathematics. Today we will discuss about all those questions related to the linear programming problem that was asked in the GATE 2013 to 2019 examples questions. We will describe all those answers with the help of the shortcut tricks. Myself Dr. Garg. You can simply follow my YouTube channel here where you can find all those previous year videos related to this GATE mathematics are there. You can see the linear algebra questions of this GATE 2022 and you can see all those previous year lectures related to the GATE 2021, GATE 2021, GATE 20 and then many more are there in my YouTube channel. So let's start with this video. So first of all, you have to read, remember that I already told you many times you have to read the statement very carefully. So what is given to you, consider the linear programming problem and S denotes the set of all the solutions of the above problem. It means they are talking only on the solutions. Are they talking about the feasible solution? No. Are they talking about the optimal solution? No. So it means that's over. That's a very simple answer about that. What is the meaning of the solution? The solution which satisfied only the constraints. That's the meaning of the solution. Any of the LPP, any of the point which satisfy these two conditions are called as the solution. So look at there is no need to solve the problem. There is no need to draw the graphically. Just look about that. S is empty. Can you see any of the pair x comma y which satisfy this condition? Clearly says that 0 comma 0 satisfied. So S is a non-empty. S is a singleton set. So one point is 0 0 satisfied. Is there any other point satisfied? Clearly says that 1 comma 1 is also satisfied because 2 plus 3 5 less than 16, 1 plus 4 less than 16. So S is not a singleton set. It consists of more than one element. S is a line segment. S has a positive area. So out from this. Now if you look about this graph, the first value is 2x plus 3. So it is my 8. It is my 16 over 3. And the second is it's a 18. Second value is my 18 here. And 18, that is a 9 by 4. So 9 by 4 is definitely here. It's a 5, so it's my here. Now what is that? What is that? This is a less than portion. So this is my solution. Remember, if you look about this, then you are talking about the feasible solution, but we are talking about the solution. So you can see this is the complete solution of this. So it has a negative area also because up to here is a 0, otherwise negative. So this option also cancel. The right answer is only C is my correct option. Look about the another one. So consider following LPP problem here. So clearly says that how many number of the variables? So it's a 4 variables. So clearly says that graphical method is not applicable. So once graphical method is not applicable, then you always look for the one thing called as the dual problem. So what you can do is consider the dual problem as y1 and y2 are the variable. You can quickly write the dual problems as here 5y1 6y2 1 and 2, that is a 1y1 plus 2y2 6y1 2y2 7y1 9y2. So since it's maximization, problem will be minimization. So it is my greater than of there. So what is the coefficient of the x is 1. This is my 3 6 and minus 1. Now that's over. Now if you want to draw the graph, you can see from here for the first value is a negative, x2 is negative, so the graph will be here. This is corresponding to my fourth line B. If you look about here, it will be 1, it will be 1 by 3. So it's a 1, it's my equation number 3rd. This is a 3, this is my 1 by 3. So it is my here. This is my equation number 2, that's a 3 by 2 and it is my 3, and this is my 1 by 5 and here this is my equation number 1. Now what is the remaining portion is there? You have to find all those portions which are greater than here. Only these are satisfied. Fine. So once it will be satisfied, what is the corner point of this? 0 comma 3 by 2 and 3 by 2 comma 0. What is the objective function of the dual is? Minimization of 20y1 40y2, and we know that optimal value of the dual, optimal value of the primals are same. So you can see what is the value of the z at here. It is my 20, that's a 60. What is the optimal value at here is again 60. So the right answer of this problem is my Minimum of 60 and 60 is 60, so that's the right answer of this problem. Okay, look at the question number third. This is related to the 2014. That's a very simple. There is no need to solve them. You can see this is a primal problem. This is my dual problem. So just read about this one. What is the meaning of that? If variable x3 is unrestricted, corresponding corresponding third constraint, because it's x3, so the third constraint satisfied as equality. You can see that satisfied. Again, what is the meaning of that? Third constraint is as equality. Third constraint equality means third variable is unrestricted. So it means this option cancel, this option cancel, because third are there. Now since it is a minimization, we need all are greater than sign. If it is a maximization, we all needs less than sign. The first problem satisfied because it's a greater than sign, so it means y1 is also greater than b. Second is, since it is a less than sign, it's a less than sign which is opposite of this, so y2 is my less than sign. So look about this option is only these options is the correct answer, rest all options are cancelled. So there is no need to solve the problem. Any of the constraints are equality, the corresponding variable is my unrestricted. If variable is unrestricted, corresponding are my equality. Okay, look about this one. So this is a very simple, you can solve it in a very simple manner. So it is my 4, it is my 8, this is my equation number 1, this is line number 1, second is my 5, and this is my 2. So this is my 5, this is my 2, and what is your portion is, this is my feasible area. So what is the corner point, what is how you solve this one? You can clearly solve this one, you can subtract them. So 4x2 is my 2, x2 will be my half. Once x2 is half, you can substitute here, x1 will be 16, 15 over 4. So this point will be my 15 over 4 and 1 by 2. So this point is my 0, 8, this point is my 5, 0, and you need a x plus y, x1 plus x2. So corresponding to this, it is 8, corresponding to this is 17 by 4, corresponding to this is my 5. Clearly says that this is a minimum point. So 17 by 4, you can convert them into the 4.25 is the right answer. Look about this one. So again, that's a very simple. Either you can write the dual of the problem, but it's a very simple if you draw the graph of this. What is the first line? 2y minus x. So when y is equal to 0, x is my minus 2 and it is a 1. So this is 1, this is minus 2. You can write like here. X, this is the line corresponding to this. This is line of 3y minus x is equal to 0. And this is the line corresponding to 2x plus 3y is equal to 10. Now what is the common area of this? So we need, this is a less than 0. So this is the portion which is below of this, which is my greater than 0. So it clearly says that 1, 0 satisfied. So here is my shaded portion. This is my feasible area. So once you know the feasible area, then you have to find the corner points. So how you find this? This point is my 0, 0. This point is my 0, 1. You need this point. This line is my x is equal to 3y. This line is 2x plus 3y. 2x plus 3y is equal to 10. And this line is my x is equal to 3y. So if you substitute here, 6 plus 9y is 10. So y is equal to 10 over 9. So x is my 30 over 9. So this point is my 30 over 9 and 10 over 9. Now you find this point. This is the line corresponding to 2y minus x is equal to 2, and here, so 2x plus 3y is equal to 10 minus x plus 2y is equal to 2. So I can multiply this by 2 and add them. So it's a 0. So 4 plus 7 is 14. So y is equal to 2. Once y is equal to 2, you can substitute here. It's a 4. Its x is equal to 2. So this point is my 2, 2. Now you can find the value of the z. Value of the z at this point is 9. Value of the z at this point is 36. Value of z at this point is 0. Value of the z at this point. So it's my 10. It's my 10 plus 10, 20. Fine. 10 plus 10 is 20. So if you find the value of 2 comma 2, what is the value of this? This is 6 plus 18, sorry, it's a 24. So it's a 24. So which is the minimum is, and you need a maximum value, so that's a 24 is the right answer of this problem. Now you can see again, this is a question 16. So again, this is a 3 variable, you have to convert into the 2 variable. How you can convert them? You have to use the dual variables. So I consider this as a y1, this as a y2. The first one is 10y1 plus 2y2. Problem is maximization. Now it's a greater than of first value 11. Corresponding to y is y1 minus of 2y2. What is the coefficient of y? Is 0. Minus y1 plus y2 is greater than of minus 1. And your objective function is 1y1 here. So maximum value of this and minimum value are same. Now if you draw the graph of this, that's a very simple again. How you can draw the graph of this? It's 11 by 10 and it's 11 by 2. So you can write off this line. This is the graph of first. Y is equal to, this is line of second. y1 minus of 2y2 is equal to 0. And the third one is when it's a 1 comma 0 and it's a minus 1 comma 0. So you can write like of here. This is the graph of this. So what is the common portion inside of this? The first value is greater than 0. So the first value is greater than 0, that's upside portion, and this is my common area. So once this is a common area, you have to find the coordinate of A, B and C. That's very simple. This line is my 10y1 plus 2y2 is 11. This red line is my third one, minus y1 plus y2 is equal to minus 1. So I can solve this line and this line. That's very simple. I can solve the coordinates of this. You can add them. y1 is 1, y2 will be my half. So this is the coordinate of first line and second line. So that's the coordinate of A, 1 comma half. You can solve this line, that is the, of these two. How you can do that? You can add them. But is the value of the y2 is 1 and y1 is 2. So this coordinate is 1 comma 2. How you solve this one? So that's a line of this and line of this. So that is a this and this. I can multiply this by 2 and subtract them. So it's a 12 y1, it's a 13. So y1 is my 13 over this. What is the y2? I can substitute here. What is my y2? So if you substitute this value, you will get as 1 over 12. So this is my coordinate of C is 13 and 1 over 12. Now you can substitute the value as y1 plus 2y2. What is the value of this is 1 plus 1 2, 1 comma 2. What is the value of this is 4 plus 1 5, and the value of this will be my 15 over 12. So you need a minimum 15 over 12 is the right answer. You can see 5 4, so 1.25 is the right answer. That is a simple graphical method. That's a very simple task board for you. There's a 3 by 2, y is equal to 3. You can, this is line number 1. For this is a 2 and 2. So this is my 2 and 2. So common area which is a greater than sign, and here what is the coordinate of this? You can solve them, you can subtract them. Clearly says that 1 comma 1 is the right answer. The corner points are my 0 comma 3, 1 comma 1 and 2 comma 0. The value of the z at point, this is my x plus 2y 6. This is my 3, this is my 2. So the minimum value is my 2 is the right answer. Now these are the major question arises. That question number 2017. No optimal solution. That's again very simple. You firstly draw this line. This is the line of x1 plus x2 is equal to 8. This is my 8. This is my 8. Then it is my 9. This is my 18 by 3. That's a 6. This is my portion. 6 and 9. And this point you can solve them. If you multiply this by 2 and subtract them, so it will be give as a x2 is my 2 and x1 will be my 6. So this is my 6 comma 2. and the third one is x1 is greater than 6. So this is the point of this. So what is the common portion of this? So you can see the first constraint is my less than sign. This is a portion. Second is my greater than. So what is the common portion of this? Only this point. Only this point is my feasible region. So there is a no optimal solution. That's wrong. So that's a 6, 2 is my optimal solution. Only one basic feasible solution, and that is optimal. That is the correct answer. More than one basic feasible solution, that's the wrong answer. Infinite many solution is the wrong answer. So the correct answer is only one optimal solution. This is 6, 2. Okay, look about this one. So which of the following is not true about this statement? Dual of that dual, primal of this, and so on. So that's every time this kind of the question asked in the examination. So before solving this, I will tell you this shortcut tricks for you. What is the meaning of this is, if the primal problem has a Z answer, the same answer of the Z as a dual. If there exists an optimal solution, same for the dual. If the primal is my unbounded solution, then the dual is my infeasible always. On the other hand, if it is infeasible, then either unbounded or infeasible, and so on. So we can see about here. The dual of dual is primal, that's my always true statement, but we need a false statement. If the primal is my unbounded, if primal is my unbounded, then the dual is infeasible. You can see, if primal is my unbounded, dual is my infeasible, so it means that is also be a true statement. If primal is my infeasible, then the dual must have unbounded. So you can see, if it is infeasible, then either the unbounded or the infeasible, but there is a word of the must have, that is my false statement. So the right answer is my C. If the primal has the finite optimal solution, then the dual also has the finite optimal solution, that is my point 2. So the right answer of this problem is my C. Okay, look what this one. This is related to the transportation problem. So that's a very simple. You can solve with any one of them. So let's start with, say, least cost method. So this is my simple. I can assign the minimum value. That's my 20. Next smallest value is my 5. I can assign this number is my, this is my 4, but it is cancelled out. So it is a 30. Remaining is here. Next number is 7 and 7. You can take this number as say 30. It is my 20. It is already cancelled. So this is my 10 here and 10 here. Fine. Now you have to find the optimal solution. So it means you have to find the Dij ui plus Vj minus Cij. If all values are my less than 0, then this is the optimal solution. So look at that. This value is there. I can assign this number as a 0. 0. I can assign this number as a V8. This is my 9. This is my 7. If this is 9, this is 3, so this number will be my minus of 6. If this is 7, this is 5, this number is my minus of 2. Now we can compute this pair as this plus this minus of 4. What is the answer of this? Minus 6 plus 8 minus of 4. You can see this number is my negative. So this number is my minus. This number 7 is a plus 1, it's again a negative. Minus 2 plus 8, again it's a negative. 9 minus 2, again is a negative. So all the numbers are negative. So it means this is my optimal solution. So what is the right answer of this? 20 into 3, 60. 30 into 5, 150. 10 into 8, 80. 9 into 10, 90. 7 into 10, 210. So this is my 300. This is my 210 plus 80. So it's a 290. 390. So it's a 590 is my correct option of this problem. Now look over this one. So that is here. That kind of the question is generally asked in the GATE examinations. We look at that. What is given to you? This is the optimal solution of the problem. Very easy. Firstly, you can quickly solve this as the optimal solution. So this is my x1 plus x2 is 1. This is the line corresponding to the 2x1, and this is my feasible area. So once this is feasible area, so the coordinates are my half comma 0, this is my 0 comma 1 by 3, and this is 0 comma 0. It is given that the optimal solution is occurring at the point case 2. So firstly you have to find the optimal solution of the x1 and x2. What is the answer of this is? Corresponding to this is 5 by 3, corresponding to this is 0, corresponding to this is my 1. So this is my optimal solution. Answer is my here. Now whenever there are here, your target is to find the largest value or the smallest value. What you can do is you have to write in terms of the slack or surplus variable. This is my here, and find all those values of the variable. So if this is there, what is the value of the S1 and S2? So if X1 is 0, X2 is my 1 by 3, so the value of the S2 is my 2 by 3. If this is 0, this is 1, 1, and here are my 0. Fine. Now remember, now there is a major complement here. So this is a complementary slackness condition. That is a very simple tips for you. What is the meaning of that? Whenever S1 is a non-zero, it means the corresponding Y1 is 0. If it is a 1, then Y1 is 0. If X2 is there, then the second constraint of the dual is my equality. That's the meaning of this. So if you write the dual of this, what is the meaning of that? The second dual, that is corresponding to the Y2, Y1 plus 3Y2 is satisfied as equality corresponding to the 5. So Y1 is my 0, Y2 will be my 5 by 3. Fine. Now you can write the first constraint, dual first constraint corresponding to this Y1 plus 2Y2, which is right hand side is my K. Since the first is non-zero, so it is my greater than of this. You can substitute the value. So 10 by 3 is greater than K. So what is the value of the K? So what is the largest value of the K? You have to find the largest value. Up to the 2 decimal places, 3.33 is the right answer. Always remember the complement slackness condition. So this is the rule for you. If the slack or surplus variable present, the variable must be 0. Like here, if the slack variable is present, then the corresponding variable is 0. If the variable is present like x1 and x2, then the surplus or 0 or the constraint is equality. Look about this one. So again, this is the relation of the primal and dual. So we again use the same concept. So which of the following statement is false? If the constraint is equality, the corresponding dual variable is unrestricted. That's true. You can see if the constraint is equality, the variable is unrestricted. So that's the first statement is my true statement. Both the primal and the dual can be infeasible. You can see if it is infeasible, it can also be the infeasible. So it is also the true statement, but we look for the false statement. If the primal is unbounded, the dual is infeasible. Again, that's true. If the primal is unbounded, the dual is infeasible. That also true. It means this is my false statement. But how? If the primal and the dual are feasible, then the optimal values can differ. No. If it is optimal value must be the same in both the cases. So that's why this is a false statement. Now look about this one. Now again, this is a similar kind of the question. Instead of the K, it's alpha. But here you can see the optimal solution is already given to you. So x1 is 3, x2 is my 0. So if I write in terms of slack variable, it is my plus s1, this is my plus s2, this is my plus s3. So I can find all those values from here. So what will happen if x1 is 0? x1 is 0, x1 is 3, so it's a 6 plus 0, so it means s1 is also be 0. Substitute here, it's a minus 3 plus 0 plus s2 is 1, so s2 will be my 4. For the third case, 3 plus 0 plus s3 is equal to 4, s3 will be my 1. Now you can see this is my present, the corresponding variable is 0. This is present, corresponding variable is my 0. x1 is present, the first constraint of the dual is as equality. So we can write the first constraint, 2y1 minus y2 plus y3. It's satisfied as equality of alpha. Fine. And y2 and y3 are 0. It is given to you. So the y1 will be my alpha over 2. Now we can write the second constraint. What is the second constraint is? y1 corresponding to x2 plus y2 plus y3, because it's a maximization, so its the problem is greater than, corresponding is my 1. So now you can substitute these, both values are 0. y1 is my alpha by 2 is greater than equal to 1. So the right answer of this problem is my here. So remember, this is my complementary slackness conditions. Now again, this is the transportation problem. So you can start with this one, very simple. You can start with either northwest or the east coast. So I can start from here. This is my 1, it is 5, then it's a 2, it's a 3, then 3 and 3 will be cancelled out. Here it's a 5 and 5 will be cancelled out. But here you all knows that m plus n minus 1. What is the value of the m? Number of the rows, number of here, and m plus n minus 1 must be of my 5. But here my 4 values are there. So that means this will give you a degenerate solution. So in order to find the optimal solution, we can assign the 1 values at anywhere. So if I assign the 1 value here, now that's simple. Now you can define the u, I can write the v. So these values are here. I can assign the 0, the corresponding value is 1, 3, 5. Once it is a 5, it is a 6, I can assign this number as plus of 1. If it is plus 1, this is 7, so this number is my 6. Now we can find this corresponding pair. 1 plus 1 minus of 2, it's a negative. 1 plus 3 minus 5, it's a negative. 0 plus 6 is a minus 8 is again a negative. Since all these numbers are negative, so what is the optimal solution of this? 1 into 1, 2 into 3, 5 into 3, 0 into 6, 3 into 5, 3 into 7. So this is my 50, this is my 7 is the 57 is the right answer. Okay, look at the last question. This is a question number 2019. This is the BFS. So they are not talking about the BF. They are not talking about the solutions. What is given to you? X1 is 1, X2 is B, X3 is my 0, X4 is my C. So I will tell you what is the BFS. Whenever there is a question of the BFS, well, how many constraints are there? There are the 2. So M is my 2. How many variables are there after the equality? So there are the 4. It means n minus m is my 2 is called as non-basic solutions or variables. Non-basic variable. What is the meaning of the non-basic variable is? Out of this x4, n minus m, that is my 2. 2 values must be 0. 2 values must be 0. But here there is only one value is given to you, 0. What is the meaning of that? Either b is 0 or c is equal to 0, then only non-basic variable satisfied. So look at that. If b is equal to 0, it means x2 is my 0. If x2 is 0, x3 is my 0, x1 is my 1, I can substitute here. So what is the value of this? It will be my 3, x2 is 0, x3 is 0, x4 is my c is my a. So what is the, you can't say. So look at this second pair, 3, x1 is 0, x2 is 0, this minus of 2c is equal to 3. So what is the c? C will be my it's a 1. So c will be my minus of 1, which is not possible because x4 is my greater than 0. But x4 is c is a negative number, so this case is not possible. Now look at this case. What is the meaning of the c0 means? x4 is 0, x1 is my 1, x2 we still find, and x3 is 0. So I can substitute these 3 values in the first pair. So what is that? This is a 3. X2 we still need to find. X3 is 0. X4 is 0 here. And for the second pair it's a 1. X2 we need to find. X3 is a 0. X4 is a 0 is here. So clearly say that X2 is my 2. Once X2 is my 2, so you can substitute here. A will be my 5. So once A will be 5, you need to find A plus B plus C. A is 5. B, what is the B? B is my x2. X2 is my 2. C is my x4. X4 is my 0. So the right answer of this problem is my 7 is the right answer. So this is the way you can solve all these previous year questions in a very simple manner. You can simply follow my playlist GATE Mathematics, where you can find all those previous year videos as I show you earlier. GATE 2017 complex analysis, GATE 2018 vector calculus, LPP, GATE 2000, and here all are available in my this playlist: linear algebra, LPP solutions of the 18th, GATE 2021, 2022, numerical analysis, all are available in my channel. Dr. Harish Garg is the here. I hope you can simply learn the concept. You can simply like, share and comment on my these videos. Best of luck students. Happy learning.